Assalamualaikum and good morning, Ms. Rahima. So today I'm going to talk about my chemistry individual assignment. So for task 1, I'm going to talk about set A. A galvanic cell consists of a magnesium electrode immersed in 1 molar magnesium nitrate solution and a silver electrode immersed in 1 molar silver nitrate solution. The two half cells were connected by a salt bridge. So I'm going to highlight we're using magnesium electrode and silver electrode. While for electrolyte, we're using 1 molar magnesium nitrate solution and 1 molar silver nitrate solution. And don't forget they're connected by a salt bridge. So for A, draw and label a cell diagram for the above galvanic cell. Why it is a galvanic cell? Because they're connected by a salt bridge and they're using two different types of electrolytes. So how does it look like? Yeah, and this is how we should construct a galvanic cell for magnesium and silver. And how do we determine which one is a positive terminal and which one is a negative terminal? So I'm using this formula to memorize which one is negative and which one is positive terminal. So for electrolytic cell, we're using A plus and C minus, while for galvanic cell, we're using A minus and C plus. So what does it mean? For anode, in electrolytic cell is positive terminal, while for cathode is negative terminal. And for galvanic cell, anode is the negative terminal and cathode is a positive terminal. And how we determine which one is the negative terminal and which one is a positive terminal for this galvanic cell? So we're going to refer this inert value. So we can see that inert value of Mg is negative 2.37 volt, and for inert value of silver is positive 0.8 volt. So since anode is the negative terminal, so we're using magnesium, which is negative 2.37 as a negative terminal, and positive terminal is silver, which is 0.8 volt as cathode. And don't forget to state the physical state of these both electrolyte. Draw the salt bridge and draw from where the electrons flow from, which is from anode to cathode. And for B, write the cell notation. This is how the cell notation looks like. Don't forget to state the physical state, which is solid, aqueous, and solid. And for C, write the half cell equation and the overall cell reaction equation. So this is how these equations look like. So as we know that anode will always undergo oxidation while cathode will always undergo reduction. So for anode, magnesium, which is in solid state, will release 2 electrons and become magnesium ion, which is in aqueous state. While for cathode, silver ion, which is in aqueous state, will receive electron from anode to become silver, which is in solid state. But we can see that in cathode they only have 1 electron, while anode have 2 electrons. So we need to balance it by multiple 2 in this equation, and we get 2Ag plus, which is in aqueous, plus 2 electron to form 2Ag, which is in solid. And to have a overall equation, we just need to eliminate both electrons, which is the same, and just combine others element, and we can get magnesium in solid plus 2Ag plus, which is aqueous, to form 2Ag, which is in solid, plus 2 magnesium ion, which is in aqueous state. And for donkey, calculate the standard cell potential. So to calculate the standard cell potential, we have a formula, which is E naught value of cathode minus E naught value of anode. So we can see that the E naught value of cathode, which is silver, is positive 0.8, and the E naught value of the anode, which is magnesium, is negative 2.37. So we just need to sub those value in the formula, and we get positive 3.17. And don't forget to state the positive sign. So since the inert value is greater than 0, it is a spontaneous reaction. And lastly, state the oxidizing agent and reducing agent. So for oxidizing agent is Ag plus, which is in aqueous, and reducing agent is magnesium, which is in solid. So that's all from me. Thank you to